In this video, we're talking about the definition of a surd as we continue with the playlist on surds, basically for students in high schools writing exams like senior secondary school certificate exam, IGCSE, and so on and so forth. All right, definition of a surd. Definition of a surd. This is the formal definition. A surd is an irrational number that can be written in the form of a root, such as the square root, cube root, etc., and cannot be simplified to a rational number. So any square root you can simplify to a rational number is not a surd. So a surd is irrational and it can be expressed in form of roots, starting with square root and all that. So more formally, we can say that if n is a positive rational number and the mth root of n cannot be expressed as a rational number, then it is called a surd, right? So to explain that a bit, if I have square root of 16, this is square root of 16, that means that is easily 4. So, and 4 is rational. So 4 does not pass for a surd. Then if I go on and say square root of 4, square root of 4 is 2. 2 is actually, 4 is a rational number because we can say it is 4 over 1. 2 is a rational number because we can say it is 2 over 1. So this cannot pass for a surd. So not surd. This also not surd. Now, if we continue and we talk about root 2. Now, root 2, try hard as you may, you cannot get it to be a rational number. Okay? So automatically it's a surd. And of course, we've tried this example, right? If you square 1, you have um you have 1. If you square 2, you have 2. Okay? Um, if you square 2 rather, you have 2. So automatically, if you square root 2, you get 2. Oh, I wrote 2 again here. You get 2, right? So you see that root 2 lies between 1 and 2. So 1 is less than root 2, and root 2 is less than 2. Root 2 is less than 4, actually. So as a result of that, because we cannot express square root of 2 in rational form, then root 2 is a surd, whereas these ones are not surds like that. So that's the simple explanation for the formal definition. So we go on to talk about conditions for a number to be a surd. Okay, just like what I've explained, a number is a surd if all of the following conditions are satisfied. Number one, it must be written as a root. So there must be a root, whether square root or cube root. So something like root 2 or cube root of 5. These are surds. Condition 2, the number inside the root must be rational. So you take the square root of a rational number, and that root cannot be expressed as a rational number, then it becomes a surd. So the number inside the root must be rational. So examples of rational numbers are 2, 3, 5, 18, and so on and so forth. All right. Because they can be written as the ratio of two numbers, like 2 over 1, as the ratio of two integers, rather, 2 over 1, 3 over 1, 5 over 1, 18 over 1. Of course, you can also have like maybe 2 over 3 and all that, right? So condition 3, the root must be irrational. So when you evaluate the root of that rational number, it must be irrational. That is, it cannot be written as a fraction. Then these conditions must be met for you to say a number is actually a surd. And I think I've given the example already, and more examples are still coming. So we have important rule for square roots. For instance, for square roots, if the number inside the root is a perfect square, the result is rational, and that makes it to not be a surd, just like root 16 and root 4 that I talked about previously. Then if the number inside the root is not a perfect square, the result is irrational, then it is a surd. Like 2 is not a perfect square, and that is why the square root of 2 is a surd. Because it is 2 is not a perfect square. So we have some examples to deal with. Um, Example 1 is root 9 is surd. Of course, root 9 is equal to 3. And since 3 is rational, then root 9 is not a surd. Is root 7 a surd? 7 is not a perfect square. So square root of 7 cannot be written as a fraction. Therefore, root 7 is a surd. Easy. Then is root 25 a surd? Of course, square root of 25 is 5. And since 5 is rational, then root 25 is not a surd. And then we have root 16. Why root 16 is not a third? So check if 16 is a perfect square. 16 is 4 times 4. Find the square root. That will be 4. So since 4 is a whole number and it's a rational number, therefore root 16 is not a surd. That is straight to the point. And then imagine we have root 18. Root 18. Why root 18 is a surd now? Uh, the square root of 18 cannot be expressed as a rational number. That's why it's a surd. But let's see to that. Imagine you have square root of 18. So check if 18 is a perfect square. Of course, perfect squares near 18 are things like 4 squared. 4 squared is 16. 5 squared is 25. Square of root 18 is 18. So it means that square root of 18 lies between 4 and 5. So 18 is not a perfect square, clearly. So step 2 now you can simplify. Square root of 18 is square root of 9 times 2. And square root of 9 is 3. Square root of 2 remains 2. So since root 2 is irrational, 3 root, though 3 is rational, but it is multiplied by an irrational number. So overall, it is irrational. So we can say that the square root of 18 is actually a surd because you cannot get a rational number from it. So we have non-examples of surds. Imagine the following. The following are not surds. Square root of 4 is not a surd because the square root of 4 is 2. Square root of 49 because square root of 49 is equal to 7, so square root of 49 is not a surd. Square root of 0.25, because the square root of 0.5 is 0.5, so it's not a surd. But then pi is irrational, but not written as a root, so this is not a surd too. Though pi is irrational, it is not written as a root, so you can't call it a surd. Though it's irrational, so e is also irrational, but it cannot be written, you cannot, but not written as a root, so you can't also say it's a surd. So a surd must be the square root of a rational number which cannot be evaluated as a rational number. Okay? So that is the root of that rational number cannot be expressed as a rational number. Then you have a surd. So then we go on to another idea, distinction between irrational numbers and surds. So just like you've seen already, a number can be an irrational number without being a surd. All surds are irrational numbers, but not all irrational numbers are surds. So irrational numbers cannot be written as a fraction, just like we've seen. Then they also have non-terminating, non-repeating decimals. So if you have terminating and repeating decimals, you can still write them as rational numbers, just like we saw in, I think, the last video or so. Then examples of irrational numbers are pi, e, and root 2, right? So these are irrational numbers. On the other hand, talking about surds, surds are irrational numbers. Just like I said before, all surds are irrational, but not all irrational numbers are surds. So surds must be written in root form, like we said. Examples: root 2, root 3, root 5. The important conclusion is that all surds are irrational numbers, but not all irrational numbers are surds, because pi and e are irrational numbers and they are not expressed as roots. So that is why they are not surds. So, in summary, a number is a surd if it is written in root form. It cannot be simplified to a rational number. Example, square root of 16 is 4, not surd. Square root of 18 is 3 root 2, it's a surd. So you should now clearly understand the difference between irrational numbers and surds, so that all surds are irrational numbers, whereas not all irrational numbers are surds. So determine whether root 4 is a surd. Of course, root 4 is not a surd because the answer is 2, which is rational. Root 6 is a surd, of course, because you cannot express root 6 as a rational number. Then determine whether root 36 is a surd. Of course, root 36 is 6, which is rational. Determine whether 11, this is surd. Determine whether 0.81, the square root of 0.81 is 0.9. So that's not a surd because 0.9 is 9 over 10, you know. So another way you can look at this, okay, I think I want to write here. You have square root of 0.81. So you have square root of 0.81. That is square root of 81 over 100. So that square root of 81 is 9. Square root of 100 is 10. So this is a rational number. And you can still write it as a decimal, 0.9. So square root of 0.81 is not a surd, you know. Determine whether root 50 is a surd. Root 50 is not a surd because root 50 is 25 times 2. So square root of 25 is 5, but you still have the root 2 there, which cannot be simplified further. Root 121 is not a surd because root 121 is 11. Root 72 is a surd because 30 you have that's 36 times 2. So that's 6 root 2. So it's not a surd. Then determine whether root 1 is a surd. Root 1 is not a surd because the square root of 1 is 1. and that is a rational number. Determine whether root 20 is a surd. Root 20, of course, is a surd because that's square root of 4 times 5. That is 2 root 5, which is still a surd. And then coming to the second half, determine whether cube root of 8 is a surd. Cube root of 8 is 2, so that which is rational. The cube root of 2 is a surd, of course, because you can't simplify it into a rational number. Then square root of 45, that's 9 times 5. That's 3 root 5. That's a surd. Square root of 90, that's 49 times 2. That's 7 root 2. That's surd. Square root of 144 is 12. That's not a surd. Square root of 3 is a surd because you can't simplify it. That it's roughly 1.732 and it's not recurring, non-repeating decimals. Then simplify root 27 and state whether it's a surd. Of course, that's root 9 times 3. That's 3 root 3, which is a surd. Tell me whether pi is a surd. Pi is not a surd, although it is irrational. The reason is that surds are written as roots and pi is not written as a root. Same goes for E. E is not a surd, though it is irrational because though it is rational, and it is not a surd because it is not written in root form. Explain why root 18 is a surd but root 16 is not. Of course, root 18 is a surd because when you simplify it, that's root 9 times 2. That's 3 root 2. You still have that root 2, which is irrational there. So that shows us that if you multiply a rational number by an irrational number, the overall answer is still irrational. Whereas the square root of 16 is 4, which is rational. Okay? So with this, we come to the end of this interesting video about the definition of a surd and how that a surd must meet three conditions. First of all, it is written as a root of and so it has a root. Number two, you have a square root, cube root, or whatever root. Number two, under the root you have a rational number. Number three, the root, that whatever root, whether square root of cube root of that rational number, cannot be expressed as a rational number itself. So it's irrational. So so that's how we define a surd. Let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed already, I thank you so much for doing that. And if you haven't subscribed, you want to do that right away and hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can also become a member of the channel by clicking on join. That gives you special privileges like getting to see some videos first or being the only one and only you can see some videos as members. You can also request for PDF copies of my notes. We can hang out together to talk about anything that interests you on my channel. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. So, like, coming your way again. Keep doing math right. Bye.